Okay, so we're going to talk about 1.6 right now. Absolute value inequality. So remember what the absolute value means, right? It basically means distance from 0. Okay, so here we have absolute value of x is greater than 3. That means we want our number to be 3 units, we want our number to be greater than 3 units from 0. Okay, so if we go 3 units from 0, that's here and here. But I want my number to be farther than that away from 0. So it's basically that region and that region, right? And if we were to write that, it's x is less than negative 3 or x is greater than 3. Now here it says you want your number to have a distance less than 3 from 0, right? So if this is 3 and here we have negative 3 and positive 3, positive 3 is here. You want the distance of this number to be in between here, right? So less than 3 units away from 0. And so the way we can write that is negative 3 less than x less than 3. Okay. So if we have an absolute value, that's a little bit more complicated. So if you have, an expression in the absolute value greater than c, that means you want the distance to be greater than positive c or less than negative c. And if you want the distance to be less than c, it means it has to be bound between negative and positive c. So let's go ahead and do this next one. Okay. So take a look here. You have x minus 4 less than or equal to 5. Less than or equal to, it means you want the distance to be less than 5. So what I'm going to do is, I have this number 5, right? So I have negative 5, less than or equal to, less than or equal to again, 5. And in the middle, I put whatever's in the absolute value. Okay, so now I add 4 to all sides. So I get negative 1 less than or equal to x less than or equal to 9. So I get here negative 1 and 9 less than or equal to, and that's my answer. Okay, next one. Here the distance has to be greater than 2. That's an or inequality. So I say x plus 7 is less than negative 2 or x plus 7 is greater than positive 2. And if I subtract 7 from here, then I have x is less than negative 9 or x is greater than negative 5. Okay, so x is greater than negative 5, x is less than negative 9. Okay, moving along. Special cases. If you have an absolute value less than negative 3, that's no solution, right? The reason is whatever comes out of the absolute value is going to be positive. So you can't have a positive number be less than negative 3, right? So that's no solution. However, if you have an absolute value greater than or equal to negative 6, well, let's think about that. Whatever comes out of the absolute value is positive, so it has to be greater than or equal to negative 6. That means this will be all real numbers. Okay, let's take a look at this one. So I have an absolute value less than or equal to 10. Less than or equal to is and. That means I say negative 10 less than or equal to this number, and then less than or equal to 10. Add 4 to all sides. Negative 6 less than or equal to 3x. 14. Divide by 3. I get negative 2 less than or equal to x less than or equal to 14 over 3. So I go from negative 2 to 14 over 3. That's between 4 and 5. And I have a dash, I connect those two. Okay, here. First, isolate absolute value here. Okay, so we're not gonna, do less and or yet. So first subtract 4. Negative n plus 1 in absolute value less than or equal to negative 2. Okay, you can't have an absolute value less than a negative number. That's no solution. Okay, next. Divide by negative 1 first. So we have negative 15 less than absolute value of negative 5m. Okay, let's rewrite that. Okay, let's just swap the order. Let's write it starting with the absolute value. Negative 5m is greater than negative 15, right? Okay, so let's think about that. Whatever comes out of the absolute value will be positive, and that's always going to be greater than negative 15. So that's going to be all real numbers. And when you come here, you just shade the entire line. Okay. All right, next. Multiply both sides by 3. 8r plus 5 greater than or equal to 21. Now, it's greater than or equal to, that means it's or inequality. So I say the stuff inside the absolute value is less than or equal to negative 21 or greater than or equal to positive 21. When I subtract 5, I get negative 26. R is less than or equal to, negative 13 over 4. Here, 8r greater than or equal to 16, r is greater than or equal to 2. So, greater than or equal to 2, less than or equal to negative 13 over 4. That's about 4 1/4. So there. Okay, here. Add 4 to both sides. I get negative a in absolute value is greater than or equal to 3. And now we have negative a is less than negative 3, or negative a is greater than or equal to positive 3. This should be less than or equal to. A, switch the sign, greater than or equal to 3, or A, switch the sign, less than or equal to negative 3. So greater than or equal to, less than or equal to. Okay, now let's move on. We touched on this in 1.4. We said when you have x minus c in absolute value, the c was the center and the r was the radius, okay, or the distance from 0. So now we need to look at what this looks like, right? So if the center of this is c, that's here, okay? And let's see how big the region is. If this is less than r, absolute value less than something, this is an and inequality. So it'll be negative r less than x minus c less than r, okay? Now, if r is my radius, that means from here, I'm going to go r units away to both sides, right? So let's go back to the equation. Let's solve this for x. Plus c, plus c, plus c. On the left-hand side, I have c minus r less than x less than c plus r, right? So look here too, those are the same values. C minus r, I go to the left r units. C plus r, I go to the right r units. So that is the inequality that I'm talking about when I say this. Okay, when I have x minus c is greater than r, again, c is my center and r is my radius. So I go r units this way, r units this way. Now though, here are my points. If it's greater than r, this is an or inequality, so I go out in opposite directions. Okay, so let's use that to come up with the inequalities, absolute value inequalities that go with each of these diagrams. Okay, so I need center and radius. Okay, so center here between these 2 points, right, is the midpoint. And remember how to find midpoint. This is -1 and 7. To find midpoint of 2 points, you add them, divide by 2. Okay, so you get 3. So the center is 3. And if this is 3 here, okay, what's the distance from the center to one of the outer points? Like from 3 to 7, that's a distance of 4, right? Okay, so 4 is your radius. So your equation is going to be absolute value x minus radius equal, not equal, greater than 4. Okay, why greater than? Because it's an or inequality. Okay, here, this is an and inequality. What are the endpoints here? -8 and 2. So -8 plus 2 over 2 is -3. That's my center. So from -3 to one of the outer points, how big is it? It's 5. That's my radius. So I say absolute value x minus -3 makes it +3. And because it's an and, less than or equal to 5. Okay, and that's this section. Thank you very much.